Greetings! Welcome to this video, which is an update of a previous video showing when temperatures of 32 degrees Celsius or greater have been reached in Canada. It also corrects a couple of small data errors. It is not necessary to see the first video to understand this one. This update contains everything from the first video, but adds more locations in order to better cover the entire country. Again, we start with Toronto as it has the oldest complete weather data in Canada from a consistent location, specifically at the downtown campus of the University of Toronto. It is important that the data be taken in a consistent location. I dwell on this point because it is a problem that plagues the Canadian weather database. Moving the collection point and then mixing data from the different locations that have some differences can easily hide, change, or exaggerate a trend. When there are people claiming that a long-term difference of a degree or two is a potentially earth-shattering event, this becomes a big deal. This should be obvious common sense, but as we know, facts don't matter when you can scream very loudly and flood the media with misleading reports. This graph shows the number of days the University of Toronto reached 32 degrees each year from 1840 until 2019. No rounding up was used. The temperature had to fully reach 32 to count. It also has a 5-year moving average. We see mostly low numbers through the 1800s. This is not surprising, as we were emerging from the Dalton solar minimum, which followed the Little Ice Age. This was followed by a significant rise in the early 1900s, then a noticeable drop by the late 1970s, and a somewhat higher level since then. We also see that a year with a lot of high temperatures can be followed or preceded by a year with very few. The second graph displays the same data grouped into 5-year periods. The last bar only contains partial data for 2019. The overall trend is very clear. It also serves as a caveat for when you see graphs that start in the late 1970s. When you see that, a warning bell should go off. Always look for what happened before the start line of any graph someone shows you. That is not just for weather graphs. That's Toronto. Let's go to Calgary, or what is now the airport. Data for Calgary starts in the 1880s. Calgary does not hit 32 so often, but we do see a similar major peak in the late 1910s and a lower peak in the 1930s to 40s. Since then, we see a hot summer from time to time, but definitely lower numbers. The 5-year graph is very clear. The period 1910 to 1944 dominates the graph. Medicine Hat hits 32 far more often than Calgary or Toronto. Nonetheless, we see a similar peak in the years after 1914 that tapers off in the 1940s. The 5-year trend graph for Medicine Hat shows that temperatures 32 or more are common, but they were more common 80 to 100 years ago. Regina has a gap in the data from 1888 to 1897. The pattern is a bit different, but the major peak again comes in the same late 1910s to 1940 period. The 5-year graph gives a clear peak in the 1930s, followed by a dip, returning to a plateau in the 60s to 80s with lower levels since then. Saskatoon also has gaps in the data in the 1890s. Here the numbers go up and down, although there seems to be a concentration in the 1930s. The 5-year data clears us up just a bit. There are alternating peaks and valleys, but the overall trend is down. Here we must pause because we have almost run out of locations with consistent data collection points. It would be good to immediately include Montreal, Vancouver, and others, but these have moved their data collection points, in some cases several times. An honest presentation has to distinguish between these. This is the tragedy of weather data in Canada. There is a lot of it, but it is chaotic. What usually happened was data was collected in a municipality. Later, an airport was built, and the weather data was then collected there. This shift usually happened between the late 1930s and the early 1950s. In some cases, there are decades-long gaps in the data. The far north above the 60th parallel has little data before the 1940s, and temperatures there rarely reach 32 degrees. There is no choice but to use some of this imperfect data. Moving from east to west, we started Moncton. St. John's, Halifax, and Charlottetown rarely or never reach 32 degrees, so for now, we leave them aside. Moncton gives city data until around 2009. The airport data starts in 1940. Moncton doesn't get to 32 that often, although it did in the 1940s and again in August 2001. The 5-year data shows the city reaching 32 more often than the airport. There are reasons to expect that, but we won't address them just now. The number of hot days peaked in the late 1940s and again in the 1990s up to 2002 before tapering off. Quebec City hasn't reached 32 with regularity except in the mid-1940s and mid-1960s. Other than those peaks, things are as they were in the 1800s. Montreal has most years hitting 32 2 or fewer times. There were peaks of 14 in 1921 and 1955. There's no obvious pattern to the peaks. 5-year data shows that since 1911, the number of days have gone up and down with no real pattern. The last 5 years are at one of the higher levels, but by no means the highest. Incidentally, there is Montreal data as early as 1742, but with long gaps and many location changes. I have looked at these pre-1871 Montreal numbers. The results were very unusual, and I hope to present something regarding those in the future. The peaks, such as they are in Thunder Bay, were in 1988 and 2001, but have since fallen to a very low level. Winnipeg had certain very hot months, such as July 1886, July 1936, and June 1988. The consistently higher years were in the 1930s. Recent levels are lower. The 5-year data shows a concentration in the years 1928 to 42, a notable peak in 1988 to 92, and then a drop to much lower levels. Fort McMurray in northern Alberta, in the middle of oil sands country, still manages to get to 32 at times. However, it has not had a peak since the early 1990s. And the largest concentration of high numbers were in the 1940s and the late 1910s. We arrive in the far west with Kamloops. The city data ends in 1950, then restarts in 1962 to 82 with the airport starting in 1950. Kamloops hits 32 degrees consistently. The city seems to hit 32 more often than the airport. The recent years do not hit the peaks of some earlier years, but the average per year does seem higher recently. The 5-year data supports that observation. Around 2000, the numbers rose to reach a plateau that appears to average higher than any of the previous plateaus. Vancouver almost never reaches 32 degrees, so we have to settle for Nanaimo on Vancouver Island. Here the airport seems more likely to hit 32 than the city. There are peak years in 1958, 1971, and 1977, but a majority of the years are at 4 or less, and there does not seem to be a trend except for a peak once in a while. The 5-year data shows a recent upward climb, and yet this apparent climb contains 3 years in 1999 to 2001 and in 2011 to 2013 with no days of 32 degrees, and none so far in 2019. In this case, the year-to-year data might be more informative than the group data. Dawson City, the center of the Klondike Gold Rush, is in the far north near the Arctic Circle. Here, a total of 4 weather stations had to be used. Since it has only hit 32 degrees Celsius a handful of times, 30 degrees was used as the threshold of a hot temperature. There was an early peak in 1898, some later peaks in the 1990s and early 2000s. The 5-year data confirms the concentration from the late 1980s to the early 2000s and a definite drop since then. It is not clear whether the different locations had an effect on these patterns. Lastly, I want to show Welland, Ontario. Why? It also has almost continuous records going back to 1872, one of the few such places. Recently, the location has been moved 7 kilometers outside the city, but in this particular case, the impact of that appears small. Also, Welland is a small city, near to Toronto, but in contrast to Toronto, which is now a large metropolis. There are good reasons to believe that large urban centers act as heat islands which raise local temperatures. This is another topic for later investigation. The chances of hitting 32 degrees in Welland were much greater in the past, and there has not been a big peak since 1988. The 5-year data clearly shows that the greatest frequency of hot temperatures was in the period 1895 to 1949. Let's wrap up this look at these 15 locations. What has been most noteworthy is the number of hot temperatures in the period 1915 to 1950. The 2 places in British Columbia are recently at a high, while the rest are at much lower levels and several are near their historic lows. This data is publicly available, and anyone who accesses it will come up with the same results. One last thing. I'm again going to ask you to be honest with yourself. Did you know any of this before watching this video? Further, does anyone in the media tell you anything about it? If the weather is so important, why do people have to spend hours digging into historical records to learn what has really happened? Please think about that. Discussion and investigation must be open and honest and based on real data that has not been tampered with. Thank you for watching.